You know, when you open an app, you're putting your trust in the company that made it. But what if I told you there are dozens, maybe even hundreds, of other invisible developers whose code is running on your phone at this very second? So let's pull back the curtain on this hidden world of modern software.
I mean, really think about it. That super slick user interface, the secure way you pay for things, that little interactive map. It's really unlikely that was all built from scratch by just one team. The reality is, most modern apps are like these digital mosaics, pieced together from components built by countless other companies. And this introduces a really crucial concept.
Yep, you heard that right. Just like a car is put together with parts from all over, tires from one place, an engine from another, electronics from a third, software is built pretty much the same way. This is what we call the digital supply chain, and honestly, securing it has become one of the biggest challenges in tech today. So if your job is to secure an application, the very first thing you've got to do is draw a map. The logic is simple, really. You can't protect what you can't see. You absolutely need to understand every single piece that makes up your software, and more importantly, where it all came from. And look, this isn't just some nice-to-have best practice. It is absolutely critical. This quote from the CIS API Security Guide gets right to the point. Every single external piece of code you use is a potential liability, a hidden backdoor. I mean, think about the huge data breaches you read about. A lot of the time, the attackers didn't storm the front gate. No, they just found an unlocked window left open by a third-party supplier. Your security is only as strong as your weakest link.
So, how do you actually map out this whole complex chain? Well, it really boils down to three pretty straightforward steps. First, you've got to identify every single component you're using. Second, figure out exactly where those components plug into your system. And third, trace the data to see precisely what information these outside parts can get their hands on.
Okay, so when we talk about these parts, the technical term you're going to hear is third-party dependency. Sounds a little jargony, I know, but all it really means is a piece of code you didn't write yourself, but your app needs it to work. Just imagine it's a pre-made part you order from an outside company for your digital assembly line.
So, how do you actually find all these dependencies? Well, you could try to read through all the source code by hand, but for any big project, that's just not going to happen. This is where specialized tools become your best friend. They can automatically scan your code, find all these third-party pieces, and help you build out a detailed inventory, kind of like a bill of materials for your software. The key here is to automate this so it's always up to date.
And remember that third step, tracing the data? Oh man, this is so important. This isn't just about preventing hacks. This has serious legal consequences. Rules like GDPR in Europe have super strict, and I mean strict, regulations about how personal data is handled. If just one of your third-party components messes up, it's your company that could be on the hook for massive, massive fines. Okay, so you've done the hard work. You've successfully mapped out your digital supply chain. You've got this great diagram of every single component and where it connects. Fantastic. But now the real challenge begins. Finding all the hidden flaws.
Right? Having the map is one thing, but knowing where the dangers are hiding is a whole other ballgame. In this complicated web of code, where should you even start looking for potential threats? Generally, the threats you're hunting for fall into three main buckets. First, you've got your known security vulnerabilities. These are flaws that are already publicly known, bugs that hackers are actively searching for. Second, there are misconfigurations. That's just a fancy way of saying human error, like a developer accidentally leaving a database wide open to the internet. Sounds basic, but it happens all the time. And third, you've got those legal risks we just talked about, using code that could get you in hot water with regulators. Now, one of the most powerful things you can do is check your inventory of parts against public lists of known security bugs, like the National Vulnerability Database. Think of these lists as the FBI's most wanted for software flaws. If a component you're using shows up on that list, you've got a problem you need to fix, like yesterday. And this really gets to the heart of it. What separates a safe, low-risk component from a high-risk one? Well, a low-risk part comes from a trusted company. It's constantly being updated, and it's clear about what data it uses. The high-risk stuff, it might come from some random source, be totally out of date, or ask for way more permissions to your data than it actually needs. So, we've mapped the terrain and we've spotted the dangers. The final phase is all about action. It's time to build a solid defense plan to manage these risks and lock down your system. Finding the flaws is a huge step, for sure, but it doesn't mean much if you don't do anything about them.
So, what's the game plan for actually fixing these issues and making your defenses stronger?
It all starts with treating your code suppliers like you would any other business partner. You've got to do your homework. That means looking into their security practices, checking their reputation, and reading the fine print on contracts to make sure they're legally committed to keeping things secure.
This all comes together in a defense plan, and this 4-step framework is a great guide. First, you evaluate the risk. Not all bugs are created equal. Second, you create a strategy for how to deal with it. Third, you actually implement the fixes. And fourth, and this one is absolutely non-negotiable, you monitor everything all the time.
Now, implementing fixes can mean a lot of different things. Sometimes it's as simple as applying a quick security patch. Other times you might need to change your own security settings. But it also means having a playbook ready for when things go wrong so you're not just scrambling. Who gets that phone call at 3 a.m.? What could shut down first? In a breach, every second counts.
And that really brings us to the single most important thing to remember from all of this. Managing your digital supply chain isn't a one-and-done project you can just check off a to-do list. It's a cycle, a continuous process of mapping, finding problems, and fixing them. Because new code is always being added and new threats pop up every single day. In the end, this is what it's all about. The whole point of this entire process is to lower the chances of an attacker finding a weakness in your supply chain and to stop sensitive data from leaking out. Every single step we've talked about serves this one critical goal. So the next time you launch your favorite app, just take a second. Remember that you're not just trusting one company. You're trusting an entire invisible supply chain of code. And the real question is, who else did they let in?